Okay, the generic knowledge so far that we have in this chapter, do you remember down a group what happens to the size? The size always increases because down a group you're coming period by period. So one shell is getting added. The reactivity usually increases because the reactivity is all about either the electron getting in the reactivity increases where in the metals the reactivity increases because metals reactivity is a function of losing an electron. And if you go down a group, the electron is far away from the nucleus. So the electron tendency for the electron to get lost is very high. Whereas if you see non-metals or if you see in halogen, their reactivity is the opposite. It is about attracting the electron. So if you are up in the group, the reactivity is the maximum. Smaller the size, more is the attractive power. Remember that. And across a period, we said that if you are on the same period, then the atomic size decreases. Do you remember atomic size decreases? Because what happens? Electrons are going on getting added in the same shell. So as electrons are added, protons are also added. So the pull is much more stronger. So you see a much more bigger atom on this side, and as you go on this side, the atom reduces. So today, based on these things, what we will do, we will cover up, we'll go line by line on these things, the alkali metals. Why I'm using the textbook, maybe I may miss out one or other thing if I teach you generic way. So let's see, group 1 is known as alkali. Keep your notebook on and keep writing. The more you write, the more you learn. Group 1 is known as the alkali metal family, and group 2 is known as the alkali earth metal family. Okay, group 1, what should be there in group 1? ऐसे लिखो तो लीना, lithium, sodium, potassium, rubidium, cesium, francium. लीना की रूबी से फ्रेंडशिप. ठीक है. Group 1 is for our study. The group 1s are known as the metals. The group 1 are known as metals. And what will be their valency? Their valency will be 1. What is the number of valence electron? 1. What do you say about the size as you go from top to bottom? If I go from top to bottom in the alkali size, the size increases. What about the reactivity? Sir, if I go down, the reactivity also increases. Remember, francium is one element out here which is radioactive. This is from your study perspective. It's a bullet points, एकदम टिक 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 लिखते रहने का, ठीक है? And thorough reading is very much required. Okay, I'm reading it now. I don't know how much this is legible for Ahiri, and you all can also open the PDF of this book which you have with you. So it says the metal in group 1 are often called the alkali metals. They are soft solid. Metal means something with which if I strike you, your bones should break. That is what is the definition of metals in our mind. But these are not the metals like your iron, vanadium, and copper and other things. These are called soft metals. So soft that you can cut them with a knife also, right? And with relatively low melting points and low densities. So you don't expect them to be very heavy. They're low densities. They are highly reactive. This is a very important point. They are highly reactive and they are stored in oil, or they're stored in oil to prevent them from reacting with oxygen and water. In fact, sodium and potassium are always kept under kerosene in lab. If sodium is exposed from kerosene, immediately it will react with the oxygen or the moisture and violent reaction will happen. Violent means, it will be vigorous. In fact, some sodium salt or some traces of sodium are there in a test tube. You should be very careful in a lab how you dispose it in the sink. Some people just throw it into the sink. Sink has water, it will immediately catch fire. So this is a very, you may expect a question to come that this reaction had a metal or an element X, which is usually stored under kerosene. So you should understand that the question is being asked either about sodium or about potassium. Understood? Okay, when freshly cut with a knife, all these metals will have a light gray silver surface, which means there is a property of metals which are known as metals are sonorous and metals are shiny. These will not be that shiny. Like if you have copper, gold, silver, they're very shiny. They have a lot of brilliance. You don't expect that much of brilliance from them. That much of shine will not be there, which quickly tarnishes and becomes dull. That's why, still, why do we call them metals? Na to ye hard hai, na to ye shine karta hai, because they have the tendency of losing an electron and becoming electropositive. Who is a metal beta? An element M Just write this reaction, okay? M transforms to m to the power n plus, write m transforms to, that is an arrow, m to the power n plus, and then write a plus, the next thing, n electrons, Ne. Did you understand what you wrote? If you lose one electron, you become m plus. If you lose two electrons, you become m2 plus. You lost how many electrons, Kirtan? N electrons. So you became m to the power n plus. This is the property of a metal. Basically, you have written the reaction. Do you want me to write, or you have understood what I asked you to write? An m with an arrow becomes mn plus n electrons. This is a generic statement that we tried to make. Okay, let's go further and what they say about alkali. Now look at this chart. I don't expect you to remember, you should not remember, but you will get a question based upon this chart. Very, very, very common question. It was there even what your school ma'am gave. Now look at lithium, sodium, potassium. Lithium is in period number 2. So it has 2 shells have been occupied. Sodium is in period number 3. 3 shells have been occupied. Potassium is in period 4. So 4 shells have been occupied. If you observe, all of them have got 1, 1, 1 valence electrons. Means all of them try to lose 1 electron. Are we fine? Right. Look at the tendency in the density. If you are going down, the density after which leave sodium, the density usually increases. The densities of rubidium and cesium are 1.53 and 1.88, which they have not mentioned, which means that the density increases as I am going down. है ना? बड़ा हो रहा है, atom बड़ा हो रहा है if I am going down. But if you look at the melting point, the melting point is coming down. Based on this, a question which is very common, it comes, can you predict the melting point of rubidium? Nobody is going to catch your throat that you should be 31, 32, nothing like that. They just want to see that are you getting a trend analysis. See, lithium, potassium, sodium, Li, Na, Ki, Ruby. Now rubidium comes. So sometimes they will ask you, sketch a graph. So if you sketch a graph, you will find that it is from 181 coming to 98, coming to 63. Can you next predict? So you just observe how much is the difference. From 98 to 63, what will be the difference? Roughly 30. So you reduce it another 30 and you can write, should be in the range of around 33, 30, 33. Nobody will deduct your marks. They just want to check whether you are able to understand the pattern or not. This is what is called trend analysis. इसको हम क्या बोलते हैं बेटा? Trend analysis. This is not periodicity. This is called trend analysis. Okay. Then if you look at the boiling point is also coming down. So in some question they may ask, this data will be given to you, but they would ask you not about these elements. They will say rubidium is the next element, or they would ask, can you predict about rubidium? That much you should know. Lithium, sodium, potassium, rubidium, cesium, francium. Okay. And hardness, fairly soft, soft, very soft. This thing is what in chemistry is called as similar property. You won't expect somebody to be here very hard, like iron. Hard, you know the definition of hard? Glass is hard? Yes. Something which glass is brittle, which is actually hitting your mind with my question. Glass is brittle. Hard means, is wood hard? No. You can put a nail inside wood. You can't put a nail inside glass. Glass टूट जाएगा, लेकिन nail को जाने. Glass से wood को scratch करेंगे तो किसके ऊपर scratch आएगा? Wood. You know how a potato is peeled by a knife? The principle of cutting, whether you cut somebody's head or a vegetable, hard substance cuts soft substance. Hard substance cuts soft substance. The potato is softer, whereas the knife is harder. With the same kitchen knife, can you cut my balcony grill? No. But with a small hacksaw blade, have you seen a hacksaw blade? That's very small hacksaw blade. You can easily start cutting my kitchen knife. How many of you girls have gone to a jeweler's shop where sometimes people come with a complaint that the ring has got stuck and the ring has to be opened? They will have a small hacksaw blade where the blade is like a thread. It is so hard. 3-4 turns they will make and the whole ring gets cut. If that is actually smuggled by somebody, he can just cut your grill in 5 minutes. So hardness has nothing with the structure. Your kitchen, I am non-vegetarian by diet. I cut a lot of meat. So I've got a, the cleaver, that big knife. That big knife will not help me cut this grill. But the hacksaw blade, will do it, will cut. So glass is hard. Hard means कोई चीज अंदर नहीं जाना चाहिए. Wood is soft. That's why you're able to put nails inside a wood. Wood is not hard. ठीक है? Hard का definition समझ में आया? Right. Now let's see the reaction of these alkali metals. Now, okay, metals and gas formation. Remember, any metal, you keep it written, whether in this chapter or some other chapter. Metal plus dilute acid. Metal plus dilute acid, any dilute acid, okay? This is a characteristic reaction of a metal. Metal plus dilute acid will give you metal salt. Because Cambridge questions will be from all chapters mixed and will liberate hydrogen gas. Plus hydrogen gas. Okay, how does this reaction happen? You take a metal, okay, and you take some dilute acid and you put some 3-4 chips of some metal. You will immediately see effervescence and gas coming out. How do we check whether this gas is hydrogen or not? Do you know the test of hydrogen? Lighted matchstick, if you bring near the test tube, then the matchstick is going to burn with a pop sound. वो भी लिख के रखिए. Test of hydrogen is always pop sound created when a lighted matchstick is brought near the test tube. Hydrogen's presence can be detected by a lighted matchstick brought near the test tube, which will create a pop sound. Means it will burn like करके ऐसे जलेगा. That is hydrogen. ठीक है बच्चा? Understood? So let's see. Gas production, lithium fizzes slowly, sodium fizzes strongly, potassium fizzes violently. What are they trying to say here? If you go down the group, the reactivity increases slowly, strongly, violently. ठीक है? समझ में आया? Next, heat produced by the reaction moves slowly on the surface, does not melt. Moves slowly on the surface. But just when it comes to sodium, melts into a ball on the surface and moves about. Sodium will burn and just move like that. Cycle का जो chain में ball होता है ना, ball bearing, this we have in our kitchen, kitchen channels. Have you seen? The balls are there. It will be moving like that. Melts and moves very quickly on the surface the moment you start heating it. Production of alkaline solution. What do you mean by alkaline solution? A metal, when you create its oxide, metals oxides are basic. When they react with water, they always form hydroxides. If these hydroxides are water soluble, then we call them as an alkali. Sodium will always create a beautiful alkali called sodium hydroxide. It's called the king of base. Equally, potassium will create potassium hydroxide, NaOH, KOH. So let's see. Metal disappears slowly, solution turns purple. Solution turns purple means, have you understood? Basic. Acidic solutions will always turn red. Solution turns purple means they have actually tried to put litmus test. Or even like KMNO4, potassium permanganate, they are always purple. Exactly like the lighter blend of the t-shirt you are wearing. Metal disappears quickly, more reactive. Solution turns purple, disappears very quickly, solution. So reactivity is increasing. Production of flame. In your ATP paper, later it will come up, like flame test will be there. All metals will show a typical color. Sometimes, see what is a flame test? Suppose a salt has been given to me, a salt. A salt will contain a cation and an anion. Let's say sodium chloride. Sodium chloride has got sodium ion as a cation and chloride as an anion. How do we check which is present or not? There will be many reactions. One of the reactions that we do in lab is called a flame test. Just take a pinch of the salt, put it on the head of a forceps and just put it on the flame. Every salt will give different colors. Like if you go to suppose if you are crossing the outskirts of an airport or something, you'll always see yellow lights. We call them the sodium lamps. Any industry, any plant. So sodium has got a characteristic yellowish flame. So it will say no flame unless held in place. This will give no flame. Hydrogen ignites and a lilac flame is produced. Itna important nahi hai abhi aapke liye, but some flame test colors will be there that we'll see when we do that ATP portion. There will be a flame color. We'll see that. Okay. Now, yes, sir, please.
So Ashwata is trying to join. She can't. She's like saying that can you try to let her in? I'm not sure what she wait. I'll ask.
Can you? No, 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 no. First of all, you do one thing. You have the call. Share the call with her. Is she? Oh, she every day joins with the same call only, right? Yeah, she joins every day. Let me check.
Wait, I'll ask her once because she says, can you tell her to let me in?
No, I don't control anyone's coming in.
1 second.
1 second. No issues. You check from there. Let me check from here. I usually don't have that. Anyone can check in anytime. Yeah, there are no restrictions in this call. Anyone can join. Ask her sometimes to turn off Zoom and again turn on. It happens. Because in none of my call this is there. You can join any call if you want, as long as you're on the right call. And she should not be on a wrong call because she every day joins online only. Had this been Dhruv or others, Shrinika and all, that mistake is expected because she joins. Check with her once.
Yes.
Right. So it's written, the physical properties of alkali metals change as we go down the group in this table. The melting points, this is important, write down. Melting points become lower and density of metal increases. So how to write it? Like, rather than writing so much in English, you write like this. Melting points lower as you go down the group. And density increases. In general question, this will be given, this chart will be given to you. So these points, melting points and boiling points decrease as you go down the group. Metal becomes softer as you go down the group. Densities increase as you go down the group, but they're saying although this trend is obscured in 13.2 because value of sodium is slightly higher, there will be minor deviations will be there. So for our sense, we should know reactivity increases, melting point decreases, boiling point decreases, density usually goes up, and metals become softer as we go down. Clear? Okay. On observing the trend in these values for physical properties, we can predict, this portion is the important portion. We can predict the values for other alkali metals. For instance, we would predict the melting point of rubidium to be lower than that of potassium by about a gap of 20 to 30. If you write 32, nobody will tell it wrong. They just want to see whether you have been able to decipher that logic or not. Okay. Now, 30° as the gap between melting points is getting smaller at each step. The gap between the melting points becomes smaller at each step. So if you see, initially the gap is 181, 98, roughly around 90s, and then it is around 60s. Sorry, 30s. So they are expecting it to be less than 30 now. So 20 to 30. This would suggest that we would have a value between 33 to 43. Actual value is 39 degrees. So what it says that in a group, you can predict certain things. You can predict. You may not be that accurate, but you will not be that off also. What is she writing now, Bitu? Is she able to join?
I told her to log off and log
on. Log off and log in. I never keep any controls. Anyone, yeah. Yeah, because might be it's keeping something from cache. She's not able to get in. Okay, now let's see. Chemical reactivity increases as we go down the group. Nothing great. We know that. All group 1 metals react with cold water. And this is important. All group 1 metals, so metals and water reaction is seen under 3 categories. Cold water, hot water, and steam. Do you understand? Okay. Apply your common sense. If somebody is highly reactive, he will react with cold water also. If somebody is moderately reactive, you have to give hot water to. And if somebody is absolutely less reactive, he will react with steam. Like say, as jewelry, you wear what? You wear silver and gold. You bathe every day. It doesn't react with water. Not even with hot water it reacts. So these are very reactive species, group 1. So group 1 will react. See, you have to always correlate and use your logic. They will always react with cold water to form hydrogen and an alkaline solution of the metal hydroxide. Alkaline solution of the metal hydroxide. Metal hydroxide means MOH, NaOH, LiOH, KOH. For you, important is NaOH and KOH. Production of an alkaline solution can be shown by adding few. Now, how do you prove this is alkaline? You put in a universal indicator. What is a universal indicator? A universal indicator is one which can be used to detect both acid and base. If you put on acid, it will show reddish in color. If you put on base, it will start showing bluish or purple in color. So it will turn purple if an alkali is produced. Universal indicator. Litmus is also an indicator, but in case of litmus, when you are testing for a base, you should bring a red litmus that will turn blue. If you are testing for an acid, you have to bring blue litmus. But universal means they are just like sticks. Have people seen like diabetic sticks and all, like that we use for our blood check and everything? You take your blood sample and you put it on that stick, the stick will take up a color. That color is a universal indicator. The reaction range from vigorous in the range of lithium, in the case of lithium, to explosive in the case of cesium. Strength of the reaction of each metal can be judged by several observations. Observations such as production of gas, whether the metal melts on in contact with water, whether the gas produces ignited, give an indication how vigorous it is. For you, what is more important to understand is, do you expect lithium to be more vigorous or cesium? Well, sir, cesium will be more vigorous because cesium is right down the group and the reactivity increases down the group. You might predict that francium at the bottom, this is another important thing. Okay, note down this. You might predict that francium at the bottom of group 1 would be most reactive of all metals. However, it is slightly radioactive. Do you understand what is radioactivity? Radioactivity means spontaneous emission of invisible radiations. If this, suppose this mouse is radioactive, this mouse is continuously emitting some invisible radiations in the form of alpha, beta and gamma rays. Gamma is known as rays, alpha and beta are known as particles. And there will be transformation. See, in chemical reactions, when carbon reacts with oxygen, carbon as an atom never changes. Only the arrangement of electron changes and it forms carbon dioxide. Radioactivity is a nuclear reaction. इसका पूरा जातवात बदल जाएगा अभी. The entire nucleus will change. Like carbon, after having beta emission, transforms into nitrogen. So nuclear reactions are completely different from the reactions of chemical reaction. So we expect francium to be more reactive because we are going down, but it says that francium is highly radioactive. Radioactive means there will be constantly transformation will take place. And every radioactive substance has got something which is called a half-life. We will read this when we go to radioactivity. Just bear. What is half-life? Half-life is the period when the substance will decay to half of its original amount. Right? So I have 10 grams of a radioactive substance. Suppose the half-life is 30 minutes. After 30 minutes, it becomes 5. The next 30 minutes, it will become 2.5. ये कभी 0 नहीं होता है. Asymptote हो जाएगा graph. Next, it will become 1.25. ऐसे करके जाता रहेगा. So, like how do you say that this bone belongs to that Paleolithic age or this age? Every human being, we have got a radioactive element in us called carbon. Every organism, carbon 14 is radioactive. Carbon 14 has a half-life of 5,000 years. Today, you cannot predict anything which is older than 5,000 years because it has crossed one half-life. So say suppose you go to Taj Mahal, you pick up a small sample of a stone or something and you put it on a radioactive counter and you can right now check what is the radiation coming out of it. There's a Geiger counter available and it will tell you how much of the life has passed. Carbon 14 is 5,000. So पूरा बता देगा कि अब तक उससे इतना radiation निकल चुका and you can immediately date back that this should be around this much. So anything older than 5,000 years ago. And see the beauty of nature. God has given something called carbon 14 which traces everything. Everything can be traced, whether you belong to CE era or you belong to BC era or what people. And BC and CE are not even, how many? 2000 years. CE means common era. We are now only in 2024. Carbon 14 has got a half-life of 5,000 years. So carbon 14 is used for dating purpose. not dating with your girlfriend, archaeological dating purpose. Okay, this means that the amount of francium, now look at francium. Francium has a half-life of 5 minutes. The moment I give it in your hand, in 5 minutes it's gone. Are you understanding? Odonil has got a half-life of say 17 days. After 17 days, the odonil becomes half the odonil that we had put. We have half-life, right? So it means the amount of francium in any sample is half just in 5 minutes. It has been estimated that there are only 30 grams of francium in existence on Earth at any moment of time. At any time in the entire Earth, how much of francium you have? 30 grams. So 5 minutes में ही बदल जाता है ना. Understood? So francium को हम पकड़ते नहीं है. Our entire discussion ends at cesium. Tell me, bacha, have you understood about group 1? So what are the salient factors? Group 1, valency 1, one valence electron, which you will be losing. So your metal, your valency is electropositive. And as you go down the group, your number of shells are increasing. So your size is increasing. Your reactivity also increases because it becomes easy to kidnap that one electron. You have to lose that one electron. And your reactivity increases. Somebody reacts strongly, somebody reacts violently with water. Potassium and sodium are kept under, remember that, under kerosene to have a contact, to abolish their contact with moisture, which means oxygen and water. Then the boiling points and the melting points do come down, the density does go up, and as a result of which you will be able to predict the melting and boiling point of an element called rubidium. Ye question aata hai. And in fact, the same question was there in that sheet which our friend Ashmita had sent. Right. Now, the alkali metals in group 1 are the most reactive that occur. Now, if you look at group 1, they are the first group and the last group is group 8. Before the last group is group 7. And as I tell you, if you turn the periodic table like a cylinder, the sheet of paper, then the group 8, that is the inert gases, form like a sort of a truce maker between two highly reactive groups. On one side, I have got the metals, and on one side, I have got the non-metals, not non-metals, the halogen family. That's why you will be studying alkali and halogen. You will be studying group 1 and you will be studying group 7. Have you understood? So we are now studying group 1. We'll attempt the questions also. So they are known as alkali metals because they react vigorously with water to produce hydrogen and an alkaline solution. Equation is like this. Ye equation bhi likh lijiye. Sodium reacts with water and forms sodium hydroxide, and hydrogen will be released. Hydrogen is released only by these reactive metals. In fact, if you go to group 2 and all, right, if you go for magnesium, वो ऐसे react ही नहीं करेगा. First it will from oxide, then hydroxide. If somebody is reacting directly with cold water, वो hydrogen छोड़ेगा, and that's only with group 1. Have you understood this part? Clear? So थोड़े से questions को देखते हैं. Let us see whether we are able to attempt these questions or not. Also, okay, Nidhi and Agiri, do read your book also. If you feel there is anything that has not been addressed, we can know. What is the name of the alkali formed when potassium reacts with water? Potassium hydroxide, write it, KOH. KOH is known as potassium hydroxide, and its what do you call, everyday name is caustic potash. Whether it is there in Cambridge or not, you should know as students of science. It's called caustic potash. NaOH is called caustic soda. Do we use caustic soda? Any use? Anyone can say in your daily life? You have this kitchen chimney, right? Yeah. And you do all Indian cooking with lots of tadka and everything. So it has got a lot of sticky oil marks on that. You know, the kitchen chimney has got baffles in it. And these baffles are supposed to be cleaned. Now, if I give you Mr. Muscle and all to clean it, it will never get clean. Rather, you just use caustic soda in some water and put them just like you're manicuring your legs and keep them dipped. Watch your favorite serial for half an hour or 45 minutes. After that, just take them out, the entire oil. They're like degreasing agent. They're also known as degreasing agent. Any sort of grease can be removed by sodium hydroxide. In fact, the red harpic, have you seen the red harpic? They also contain, there will be a smell of, you know, sodium hydroxide smell. Suppose the kitchen platform, which has got a lot of stickiness, has happened because we keep on cooking, oil sprinkles happen. get what do you call, spread on that. So if you try to clean it with any other reagent, you use little bit of that red Harpic and then just wipe it with a Scotch Brite. You don't have to do any hard work. एक बार में साफ हो जाएगा, and it will become absolutely free from any sort of grease. Write a word equation for the reaction between lithium and water. Plus hydrogen gas. Very good. Using the informations in table 13.2 and 13.3, suggest a value for the melting point of rubidium. Well, we know melting point they have asked you. Okay. Suggest how reactivity of rubidium compares with potassium. Rubidium will be reactivity with water will be much more reactive. Vigorous this reaction will be. More vigorous as compared to the reaction with halogen. Tell me, children, are you fine? Have you understood group 1 dynamics? Nidhi, understood. Kirtan, understood. We now go to, if you look at the periodic table, we were in group 1. We immediately now jump to group 7. Group 7 is known as the halogen. Before we go to the halogen family, let us understand group 7. Okay, Kirtan, how many outermost electrons? 7 outermost electrons. They will be hungry to accept 1 electron. They can't lose 7 electrons, right? So they will also have a valency of 1, just like the group that we studied right now. The difference being that one valency is an electronegative valency because it's going to accept 1 electron and create a negative charge on them. So if you look at the marriage between group 1 and group 7, it's a very, very strong marriage. Group 1 wants to lose 1 electron. Group 7 wants to gain 1 electron. So we can see some examples of sodium, chlorine, sodium chloride, sodium iodine, sodium iodide, sodium fluorine, sodium fluoride. Right? Have you understood? And let's also talk about the reactivity before going here, because in a group, in case of halogens, we will find that now the downward guy would be the reactive one, because it is the ability to accept electron. Reactivity is now defined by your ability to how quickly you can accept. So the topmost guy will be now more reactive. In the case of metals, the bottommost guy was more reactive. You will say, sir, how is reactivity changing? Well, reactivity is a function of your what you want. I am more reactive. I'm known to be more reactive by the way I lose my electron. Now the guys we are going to study will be more reactive by the way they gain an electron, and smaller the size, the nucleus just picks that electron in one go. Otherwise, there are a lot of shielding in between. And when you shield them, it's a negative girl that has to come to the house. And there are so many negative girls already, and they'll say, don't come. They'll repel it. Right? So let's go ahead and start with the halogen family. And again, same, some colors of gases and other things we'll observe here. So let's go. Group 7, the most reactive non-metals are the halogens in group 7 of the periodic table. In contrast to group 1, group 7 reactivity decreases down the group. We have covered that. Okay. For example, fluorine is dangerously reactive, pale yellow gas. Note down this, fluorine, pale yellow gas. You will forget by the time the exam happens, and that's quite natural. But you should know that with fluorine, a gas color is associated right now. Pale yellow gas at room temperature. अब कलर भूल जाओगे धीरे धीरे, वो कॉमन है, लेकिन फ्लोरीन के साथ कलर एसोसिएटेड है, वो बात याद रखिएगा. Okay, at room temperature there is a steady increase in melting and boiling points. बाबा उल्टा हो गया है, steady increase. Write down, as you go down the group, there is a steady increase in melting and boiling points, whereas if you see the metals, there was a steady decrease. Steady increase as you go down. Okay, as we go down, so you write down, as you go down, reactivity decreases, melting and boiling point increases, and slowly elements transform to solid. Iodine is a solid. Iodine is a solid. Fluorine is a gas. Iodine हमारे salt में होता है ना. Iodine is a solid. Interestingly, the lowest element in this group is also radioactive and is known as astenine. So astenine को हम count नहीं करते हैं. So when we study about halogen, whom are we studying? We are studying fluorine, chlorine, bromine, iodine, not astenine. Astenine is also radioactive. Who was radioactive in the case of metals? Francium was radioactive, right? The actual properties of astenine remain a mystery to us because we could make a good guess at some of them, because but we could make a good guess at some of them. Right? आगे बढ़ते हैं. Keywords. Now let's look at the keywords. Halogens. Do you know what are halogens? Halogens are element in the 7th group of the periodic table, generally most reactive of all non-metals. Even the 6th group is also reactive, which has oxygen, sulfur. They are also not reactive. They are also non-metals. The 5th group containing nitrogen, phosphorus are also non-metals. But amongst all non-metals, halogens are the most reactive, right? And halogens will form compounds with elements that when they form compounds, they are known as halide. Like the salt that you eat every day, sodium chloride is also a halide. It's a halide salt containing chloride ions. Fluoride salt is also a halide. Okay? Let's go on top again. So this is what is an ATP question usually. Chlorine, dense pale green gas. Chlorine has a green gas. CGI बोलते हो ना, कंप्यूटर ग्राफिक्स, ऐसे वो एग्जाम के टाइम पे आपको फॉर्मूलाज बोल देंगे ऐसे याद रखने के लिए. Chlorine, because you are not going to a lab, so you will not remember. Chlorine is a green gas. Bromine is always a brownish, like rust color. Chlorine is smelly and poisonous. Have you had water which has been bleached a lot, sometimes in some cities? So that is chlorine. Swimming pool mein jo smell aa jata hai na, that is chlorine. Occurs as chlorides, especially sodium chloride in the sea. Relative atomic mass is 35.5. What is 35.5? Because chlorine is available as chlorine 35 and chlorine 37 in the universe. So if you see, 75% of the chlorine that you get is chlorine 35 and 25% of the chlorine that we get is chlorine 37. Therefore, the relative atomic mass is 35.5. You can establish this relation, right? 0.75 into 35 plus 0.25 into 37. Acha, bromine is not a gas. Bromine is a liquid. देखो यहाँ बढ़िया चीज दिखाई दे रहा है. देखो पहले आया gas, then liquid, then we will get solid. Bromine is the only liquid. There are only 2 liquids in the whole elements that we know. Mercury is attributed to the metal family. Bromine is attributed to the non-metal family. Very good. Smelly and poisonous, occurs as bromides. Okay, a bromide is also a halide. A chloride is also a halide. An iodide is also an halide. A fluoride is also an halide. Okay. Magnesium bromide and relative atomic mass is 80. Then comes iodine. Iodine is always violet type in color, like purple they say. Gray solid with purple vapors, smelly and poisonous, occurs as iodides and iodides in rocks and all. Okay, nobody's going to ask you about these atomic masses. They do give you the periodic table in the exam. Let's see. The halogen family found in group 7 of the periodic table shows clear similarities between the elements of the group. The common properties are all of them are poisonous. All of them have a strong smell. All are non-metals. All form diatomic molecules. So we should understand what do we mean by diatomic molecules. Okay, a metal will never bond with a metal amongst the same atoms. Why? Because I as a metal and another atom of my family, we both want to lose electrons. So why will we bond? We will not bond. Whereas if you see an oxygen, chlorine, oxygen wants electron, so it doesn't get anyone, it calls another oxygen and says, why don't we pair up together? Right? So in the case of halogens, you see diatomic molecules being formed like Cl2. This chlorine needs 1, this chlorine needs 1, so they share an electron. So Cl2, I2, Br2, F2, you will see this formation. Okay. They all have valency of 1 and form compounds with similar formulae with hydrogen chloride, hydrogen bromide, hydrogen iodide. Okay, in hydrogen chloride, if you try to look at the type of bonding, what will it be? No, it will not be electrovalent bond. It will be a covalent bond. Hydrogen can never give away its electron to form a bond. Yeah, so this looks like an electrovalent bond, it's a covalent bond, right? Their compounds with hydrogen are usually strong acids. Obviously, go back to the discussion we had. Non-metals react with oxygen to form NMOs, non-metal oxides, which can be either neutral or they can be acidic. Who is a neutral oxide of a non-metal? Dihydrogen oxide, water that we drink, H2O, dihydrogen oxide. That's neutral. That's why you're drinking it. Otherwise, other oxides. What are the other oxides? SOx. SOx means X. It can be SO2, SO3. X means variable. Oxides of sulfur, COX, oxides of carbon, NOx, oxides of nitrogen. If water is allowed to react with them, they will all form acids. Oxides of sulfur will give you sulfuric acid, nitric acid. Okay. Now next. They produce a series of compounds with other elements, such as example chlorides, bromides, iodides, together being known as halides. Clear? Striking things are what? Reactivity decreases down the group, melting and boiling point increases, all are poisonous, all are, and then the physical nature slowly transforms from gas to liquid to solid. Acetylene is not studied because it is radioactive. बस इतने के ऊपर ही आपके questions आते हैं. So let's see. Chlorine 287, bromine 77. All of them need one electron. So this is in which period? Period 3, because it has got 3 shells. This is in period. Okay, fine. Now melting point. If you see, the melting point is increasing, the boiling point is increasing. State at RTP. RTP stands for room temperature and pressure. So gas, liquid, solid. Color plain green. Color itna tension mat lijiye abhi. But you should just know that bromine you know, iodine also you know. Now the halogens themselves can't react directly with metals to form metal. Okay, halogens themselves can react directly with metals to form, not can react to form metal halides. So you can write a reaction here. Metal plus halogen. Write down in bullet points. Metal plus halogen will always form metal halide. And you can put one example. Sodium plus Cl2 will form NaCl. Balance the equation. 2Na plus Cl2 gives you 2NaCl. 2Na plus Cl2 gives you 2NaCl. Chlorine you don't get as chlorine. Chlorine will be available as a molecule, diatomic molecule. There are gradual changes in the properties between halogens. As you go down the group, the boiling point increases. The physical state of the halogen changes from gas, liquid to solid. Going down the group, the intensity of the color of the element also increases. Look at the intensity. We had pale green. And slowly as we come down till iodine, we get purple. Purple is much more darker as compared to this. Following these trends, it should not surprise you to know that fluorine is pale yellow. So fluorine, nobody spoke about fluorine. Fluorine iske upar hai. Pale yellow, one step darker, pale green, reddish brown, grayish black. Acetylene is radioactive. You won't be able to see also. Flame test. But every time it is transforming, right? Chemical reactivity of halogens. So I think you can now predict in halogens, the reactivities are always going down the group. Fluorine and chlorine are very reactive because they are at top. They combine strongly with both metals and non-metals. A piece of Dutch metal foil, an alloy of copper and zinc. Dutch metal foil, let's write this also. Dutch metal foil is an alloy of copper and zinc. Dutch metal foil, copper and zinc. They will burst into flame if placed in a glass jar full of chlorine. When chlorine is passed over heated aluminium, the metal glows white and forms aluminum chloride. Chlorine, see these no, you won't get a question that write this reaction. The question will be given as a part of a story, then you should be able to relate. Chlorine passed over aluminium, that too heated aluminium, then it glows. Do you know in era during the start of industrialization or before that, when electricity was not there, so people used to, drama and plays used to exist. Ye Ahiri and Nidhi can hear this. Drama and plays used to exist. So we had this concept of theaters, not amphitheaters, theaters. So theaters, the stage has to be lit. So what they used to use calcium oxide. Calcium oxide is Chuna, CaO. Calcium oxide, when burnt, burns with a bright light. The stage, that's where the word comes, limelight. Oh, looks like nowadays you're in limelight. Limelight is very, very bright. Calcium oxide is known as lime. So lime used to be burnt to illuminate the stage. And from there the word comes limelight. ये भी interesting चीज है. What is limelight? We use it as a jargon in English, saying that nowadays you're in limelight. The limelight means you're under, there's a lot of brilliance around you, you're carrying a lot of aura, and that aura is coming because you're being compared to the light or the brilliance that is produced when calcium oxide is being burned. Okay, aluminum also reacts strongly with bromine and iodine. So this part, they have not written the reaction. In your exam, you will not expect this reaction to come, but they will ask you, write the reaction of aluminum with bromine. Same thing, same family, na? खाली ये चीज change होएगा. Okay. Now, the reaction between a dry mixture of powdered aluminum and iodine can be triggered by adding just few drops of water. The reaction is highly exothermic. You know, exothermic means a lot of heat is liberated. The reaction is high, and some of the iodine is given off as purple fumes before it even has a chance to react. Hydrogen will burn in chlorine to form hydrogen chloride. Carried out different way, the reaction can be explosive. This is hydrogen chloride. Chlorine dissolves in water to give acidic solution. In those cases we saw dissolves in water. He just told lithium plus water will give lithium oxide and liberate hydrogen. Look here what is happening. Chlorine dissolves. This is ulta. There you got a base or an alkali. Here you will get acidic solution. This mixture is called chlorine water and contains two acids, hydrochloric, hypochlorous. Hypochlorous, write this reaction also. Cl2, chlorine reacts with water to give you hydrogen chloride, but okay. You might have one confusion, sir. What is the difference between HCl when read as hydrogen chloride and hydrochloric acid? HCl, when it is as a gas, is called hydrogen chloride. HCl in the presence of water, aqueous, is known as hydrochloric acid. And this is known as hypochlorous acid, HClO. HClO, hypochlorous acid. So chlorine and water is always deadly. This reaction was the question that Ashmita had asked, if you remember. And in that question, they just changed potassium with chlorine. Sorry, potassium chloride, bromide with potassium bromide. You can see my answer. Okay. Chlorine water acts as an oxidizing agent. Chlorine water acts as an oxidizing agent. What is an oxidizing agent? An oxidizing agent is one who himself gets reduced but oxidizes the other person. Oxidizing agent will himself get reduced. Okay. Hypochlorous acid can give up its oxygen. Give up its oxygen. Somebody who loses oxygen is known as reduction. I lose oxygen. I am getting reduced. That means I am an oxidizing agent. I am oxidizing somebody else. And the fellow who reduced me will be known as the reducing agent. Okay. It also acts as a bleach, hypochlorous. That's why chlorine is added to water. And if you swim too much in chlorinated water and you wear sunglasses and swim in it, the moment you take out your sunglasses, people will call you a panda. Because your entire body will get chlorinated except your eyes. So you look like a panda. Have you seen people? Like they will wear swimwear and go, whichever portions were exposed, those portions will have a different color. Yeah, tan ho jata hai. Okay, so you get bleach. So it also acts as a bleach because some colored substances lose their color when they are oxidized. This reaction is used as a chemical test for chlorine. Chlorine is known as a bleach. Damp litmus or universal indicator paper is bleached and held near the gas. Okay, halogens become steadily reactive as you go down the road. It becomes steadily less reactive. This we have understood. Now, this is important. Halogen displacement reaction. What is a displacement reaction? I always say displacement reactions are those in which a more reactive element will displace a less reactive. Typical Bollywood film type story. A rich guy with more bike and stylish car will take the girlfriend away from a poor guy. That is called displacement reaction. That's called single displacement reaction. We have another called double displacement reaction. This one will take away this one's girlfriend, that one will take away that one's girlfriend. That's called double displacement. So this is single displacement, but this is a halogen displacement reaction. So do you understand? Halogen itself will displace another halogen. Which halogen will displace? The more reactive. So if I'm having a reaction between, say, a chlorine and a bromine, the chlorine guy will be able to displace it. Let's see what it says about. shown in the lower part of table demonstrate the order of reactivity. So we know the order of reactivity. On top we have got more reactive. Who are more reactive? Chlorine, chlorine are more reactive. Then comes bromine and others. For example, if you add chlorine to a solution of potassium bromide, look, potassium bromide. Who is the halogen there? Bromine. Okay, the chlorine displaces bromine. This is called the halogen displacement. Chlorine is more reactive than bromine, so it displaces bromine. This question was there, which Ashmita has asked. How state through a reaction, how will you show that chlorine is more reactive or bromine is more reactive than, say, iodine, or chlorine is more reactive than iodine? So chlorine is more reactive than bromine, so it replaces bromine and potassium chloride. Suppose this reaction was with iodine, we would have had Ki, potassium iodide, react with chlorine and potassium iodide. That's what I wrote in the answer. It will form potassium chloride and iodine will be released. Potassium bromide solution is colorless. It turns orange when chlorine gases. So this is colorless and orange. In the case of iodine, we will, in the case of chlorine, we will write green. In the case of, it's not chlorine, iodine, we will write purple or blackish. Purple, usually the color that we use. Chlorine will also displace iodine from yellow brown. Okay. Sorry, not purple, yellow brown, darker.
Yeah, it's something else. It's colorless, but it's still in its reacted. It's still has color.
No, it's not like that. Look, this reaction and this reaction are different. Here we are comparing chlorine's ability to kick out bromine. Potassium bromide or potassium iodide is a colorless compound, right? Then you brought chlorine in contact with them. First you ask, is chlorine more reactive than the halogen present here? In this case, yes, in both the cases. So a chemical, how do you know a reaction? Color is also one of the indicator of a reaction. There are color. So you find that it has formed KCl, KCl. Everything was colorless till here, but you are displacing bromine now. So you will see fumes coming out of the test tube, which will be orange in color. Bromine is orange, or you will see a little bit brownish. And in this case, yellow-brown. Iodine, you will see yellow-brown fumes coming out. So this is a test for the presence of iodine. So keywords: halogen displacement reaction, reactions in which a more reactive displacement is in which a more reactive element, halogen displacement, a more reactive halogen displaces a less reactive halogen from a solution of its salt, Clear? Always see these tables. Reaction with colored dyes. Chlorine bleaches easily because chlorine is very reactive. If you have chlorinated water supply in your house, please be careful washing your printed garments. They will lose their color. बोलते हैं ना, it's common question among ladies, साड़ी ये रंग तो नहीं छोड़ेगा? उससे पहले पूछिए आपके घर का पानी में क्लोरीन कितना है. अगर क्लोरीन है तो रंग छोड़ देगा. Chlorine is strong. Bleaches slowly. Why? Less reactive. Bleaches very slowly. Okay. Iron wool. Iron wool reacts strongly to form iron 3 chloride. Iron wool, have you understood? A wool made of iron. Okay. And needs heat to start. This will need continuous heating and reacts very slowly. This is showing our reactivity. Chlorides. So chlorine, obviously there won't be any reaction. But with chlorides and bromine, you don't expect any reaction. Chlorine is more reactive, na? Okay. Bromides. Bromides and bromides no reaction, displaces bromine. This is, okay. See, this is chlorine and bromine. So if you see bromine and chlorine, now what will happen? Chlorine will displace the bromide. You are going to study this with respect to this. Have you understood? Okay. So all this we have discussed. We now come to noble gases. Noble gases, group 8. What is the valence electron? 8. What is the valency? 0. Noble gases do not need any electrons. They do not react. They are inert. And what is the family comprising of? So we have helium, which is a single shell entity. So we have a duplet as a criteria of stability. After that, octet is the criteria of stability. Helium, neon, argon, krypton, xenon, and radon. Radon is again radioactive. Okay, so if we go, when Mendeleev first constructed this periodic table, I told you, right, that time the inert gases were not discovered. Okay, part of his triumph was to predict the existence and properties of some undiscovered. However, there was no indication. See, these books, they will always highlight the drawback of Mendeleev very nicely. However, there was no indication that a whole group of elements remained to be discovered. उसने जो बाकी काम किया वो नहीं highlight करेगा. Okay. Now, because of their lack of reactivity, there was no clear sign of their existence. That is one fine thing. You don't get to know. Okay, let me tell you. Suppose in a warfare, you don't get to know about the enemy position because the enemy is not making any movement. Doesn't fire, doesn't move, doesn't go this way, no movement. So these inert gases show no reaction. If they're not showing any reaction, you don't get to know their identity, whether they're existing or not. आप अभी जमीन खोदते खोदते तो elements नहीं ढूंढोगे ना, because they may be gases also, right? Now there was no clear sense. However, analysis of gases in air also contains argon, right, by John Strutt, led to the discovery of argon in 1894. And they are very, very trace. That's why argon as a gas is extremely costly. Helium is extremely costly. When people say, in my birthday party, I had helium balloons, say, what nonsense are you saying? If you add up the birthday budget of all your birthdays of your life also, that helium balloon you cannot purchase. It's so costly. Any gas which is lighter than air. Shall I tell you? But don't practice that at home. When I was at almost say your age or a little bit less, so since we used to stay in townships where we had natural gas supply, natural gas, like you have LPG, we used to have natural gas, just like Delhi and Bombay. And that gas they used to charge us 2 rupees. It was free. In Assam, other they will flare it. So when my mother used to sleep, I used to take out the pipe and fill them in balloons. And then just tie the balloon and release it. All dangerous activity. Okay. Even if you fill this LPG, see, when you study science, ask yourself a question. You are on which floor right now? 13th floor. Will the water come up directly to 13th floor? No. You need a pump to pump the water because water is heavier. Have you ever heard of LPG gas pump? No. Where are the manifolds? Right at the basement. Once they turn on the cylinders, the gas reaches us. Not me. It goes till 19th floor. It will go even higher because it is lighter than air. And it will take some time to come. So if I actually inflate a balloon, the balloon will also rise. As simple as that. Like करना नहीं है, दोनों बड़ी काम है. Yeah. So there was no suitable place in the periodic table. Now, when they're saying periodic table means they're referring to the Mendeleev's periodic table. A periodic table for an individual element with argon's properties. This pointed to the existence of an entirely. Now see, Strutt discovered only argon. But argon could not be placed anywhere in the periodic table. What is that periodic table? Mendeleev's periodic table, right? So if I try to place argon, it is disturbing everyone. Then people, it's stuck knowledge. Whatever we have is always a group of elements. That means ये argon अकेला नहीं होगा, इसका भी एक group होएगा. And if that group comes in, it can fit in the periodic table. Okay. So this pointed to the existence of an entire new group, helium, which had been first detected by spectroscopy from light from sun during an eclipse, and the noble gases isolated and so and so. The radioactive gas radon was the last to be purified in 1909. These are very, very trace gases, children. Okay. All of the, this is only for literature type, or let's just see, all of the noble gases present in the Earth's atmosphere make about only 1% of the total, though argon is most common. Argon in the Earth's environment, if you take in percentage, is almost in decimal percentage. Okay. These gases are particularly unreactive. They were sometimes referred as inert gases, means they did not react with anyone. However, since 1960, some compounds of xenon and krypton have made their name and was changed to the noble gases. The use of noble gases depend upon their unreactivity. Helium is used in airships and balloons, light and unreactive. Argon, helium is also used as a leak detection test. Anywhere in a very high level, see, you can't have everything that is 100% leak proof. So when you want very high order leak test, so they will rather say check the process rather than doing the test. The test is very costly. Helium as a gas, if you are having two flanges which you have screwed and you want to find out there is leakage or not, then generally what do we do? How do we check leakages in gas pipe? We will just take soap solution and we'll take a cotton or some cloth, we'll dip it in some prill or some sort of a detergent and we'll just put it around that place. If it bubbles out, that means gas is leaking out. But if you have very minute gas leakage, very, very high order, you want to check up, then HLT is done in industry. HLT is known as helium leak test. But that is very costly. So people rather say, check the process once again rather than employing this. Okay. And brightly colored, and so argon is filled in incandescent light bulbs. You know, light bulbs have got a element called tungsten, which forms the filament, and the filament burns. So we need to have a atmosphere inside it that it does not get oxidized. If you put oxygen inside light bulbs, then what will happen? It will oxidize, right? So what do we put? We put argon inside it. Generally, now you may ask, sir, that means you mean to say all the bulbs which are hardly costing me 40-50 rupees in the market, they're all filled with argon? No, they're filled with nitrogen. They're filled with nitrogen. The best, nitrogen is also known as, nitrogen is next to inert, which is like the poor man's inert gas. It's inert, it's very inert, it does not react. Say suppose your AC pipe, there is a leak test you want to do on your AC pipe. We will always do it with nitrogen. So we will fill nitrogen in this pipe and we'll seal on both sides. We'll see if there's a pressure fall. If the pressure falls, that means there's a leakage somewhere. Or suppose you have to, like when this building was handed and you now need to put on your new air conditioner. Before putting on your new air conditioner, you will be putting one unit inside your house, one unit outside. How do you know there is kachra in the line or not? Because you know in AC, right? Once the compressor gas will be flowing all through this pipe. So what we do nitrogen purging. The technician will say, sir, nitrogen purging karega. Nitrogen purging means you'll blow the pipe with nitrogen in a way to make it chemically inert. That's why your chips, they're all nitrogen packed. Nitrogen does not react, and nitrogen will not have any oxidation effect. If there's no oxidation, chips don't get stale. All the packs of chips that we get, they're all what? Nitrogen packed. I can't give you an, okay, sir, can we use argon packing? Yes, you can. But can you afford argon packing? No. So what do? We use nitrogen packing. Nitrogen is very inert. The use of noble gases depend on their unreactivity. Helium is okay. We've done the best known use of noble gas perhaps nowadays is neon light. The entire Times Square that you see is all neon lighting. Okay. The brightly colored advertising light, and different gases have different colors. So this is all about neon gases. We have discussed this also. Atoms of noble gas do not combine with each other to form molecules or any structure. Melting and boiling points are extremely low. Helium has the lowest melting point of any element, cannot be solidified below. All these properties to the atoms of the noble gas particularly being particularly stable. The electronic configuration of atoms of noble gas are energetically very stable. This means they do not react readily with other atoms. In many, okay, we have crossed our time. Okay, this means changes. Okay, this part is fine. After that, we have changes across a period. This thing we have covered already. Have you noticed changes across a period? The atomic size decreases. This part we have covered. So there is a section called transition element. Maybe one more class we will finish it. And transition element, very small. We'll stop here. Read up to inert gases in your book and then see. It's hardly a small paragraph. After this, we end chemistry so far. And then we will do practice papers and practice questions also. If there is any chapter in your section which you still need help with, do let me know. Okay. So read up till inert gases. Transition we will get through in one go. And then we will have revision of paper revisions we will have. That is important for us for our grade 9. Righto. So we had a marathon class. Thank you then, and we'll catch